Okay, so let's see, where did we stop last time? I guess we were towards the end here. Okay, so I guess okay. Okay. So last time we were at the last lecture of sorry, the last slide of the previous lecture, and I will leave the remaining for you just to read. It was an additional example, and if you got questions, please ask. And today we are starting this new lecture, more theory, unfortunately, but we will talk about arrays today. Just want to get this as full screen. Let me see. Okay, good. Hopefully at the end I can write. Perfect. So, open the camera here. Questions before we start? Let me see. For lab 1, question 2, would an input of 000 could count 5-digit number? I guess the question already mentions that you have to handle zeros, like the leading zeros. They shouldn't be part of your digits. Can the 5-digit will start with a 0? This is already also mentioned, as I was saying, Nicole, in the question. Leading zeros shouldn't be part of the digits. Okay. Do we consider as a 5-digit number? We're talking only about integers, Ahmed, in this. I'm having problem trying to read my code into GitHub, something about permission error, wondering if this is, okay, if this kind of specific action, this kind of specific lab questions, let's discuss them in office hours. But let me mention one thing about the lab. One important thing is, as I said last lecture, please forget about the GitHub auto grading for now. Good. You can completely check your code locally through running all the test cases in Eclipse. Currently, we are exceeding our GitHub quota for running things on their servers by the test cases, as I said last lecture. And this doesn't affect in any way your development of the lab. You can also submit as much as you can comment as much as you can, but don't look into the auto grader because I receive multiple emails about this. Okay, do you have to comment your code? Please do so, yeah. Try to comment, try to add comments as much as you can. This is a professional way of making your code readable to others. You are asked to add useful comments. In further labs, we will ask you to do specific things about comments. It's like we are developing your skills one by one, right? So in lab 1, you started adding comments. In lab 2, you might be asked to add comments in a specific way. In lab 3, you might get penalized for not adding certain comments. And this is how you should kind of develop over the course. Okay. So let's start for the lecture for today. So we have dealt with arrays multiple times. We have also taken one lecture with examples about arrays, and it was all hands-on. So now let's again take a step back and see the basics or the general rules of arrays in C. Good. As we said last time, an array is a data structure that has certain constraints in C. These constraints come from the fact that all the elements of the array are contiguous in memory, which means they are adjacent to each other to enforce locality, right? And this is because they have to, this is the reason that they have to be of the same type. So all the elements can be, for example, int, double, any type, character, but you don't have a mix of these, right? Later in the course, maybe the last 2 lectures, we will see if you want to have a certain data structure, a certain organization in the memory that combines multiple types, what you would do, right? We said also that the name of the array is reflecting the address of the first element, right? Okay. To refer to an individual element, you have to mention the array name and then use the index for this. For example, A of 0 is the first element of the array. A of 4 is the fourth element. Fourth element means it's 0, 1, 2, 3, 4. It's in fact the fifth element, right? Because we start from 0. But generally, it's the fourth element of the array. Okay, we already mentioned that. Okay, arrays in C, and this is a very important thing. Arrays in C are not automatically, they are not dynamically allocated. What we mean is you have to have the fixed size of the array at the beginning, right? You have to say, for example, when you define an int of an array, you would say int A, and then this is of size 10. And as we will see now in more details, you can also assign the size in a different way, like initializations, right? For some reason, the notifications are also reflected. That's annoying. Okay. So what I can do is try to share from my laptop and lose hope using the tablet for today as well. Okay. Okay, let me check questions until this opens. Is array the same as list in Python? Well, the easy answer is yes, with certain differences. Good, but I would say don't care about the differences for now, Fatima. So take it as a yes. If further in the future you see differences, then I would say there are differences, but this is not the time to discuss them, right? Okay. Come on, I've already closed that. Okay, here we are. Okay, so let's forget about this for now. Good. So let me put this up there. Okay. So the general rule of defining an array in C is you specify the data type. Again, for example, you say int, and last lecture we discussed types in details, and then the array name, which has to be a valid variable name, and then the array size, and this has to be a static. I mean, you don't define it as static, but it has to be like a value that doesn't change over time. It's not a variable, for example, right? And then the other thing, okay, when arrays are defined, they are not automatically initialized unless they are static. That's something that I would say is C version dependent, right? So we said before that all variables in C are not automatically initialized, right? And in one of the lectures said array might be an exception in one of the C versions, but because the course is assuming the oldest C version, which is C98, in C98, arrays similar to all the variables, they are not automatically initialized again, unless the variable is static. So unless the array is static, right? What I would say is if you try your compiler, in fact, you might get, if you try to define an array and then try to print it, it might get, in fact, everything as 0, because you might be using a version of C that is, it most likely that's the case. In fact, you're using a version of C that is up to date. It's more recent than 98, right? But take it as a general rule, because in 2SH4 we only assume the minimal like support across all platforms to be platform independent. So arrays similar to all variables, they are not automatically initialized, right? Good. Here is an example of defining an array. The type is double. The name is AA. As you can see, the name can be anything, right? And then this is the fixed size. Good. You can also define arrays using the same way you define variables, declare them in the same line. Okay. The array size, as we said, it has to be constant. In later versions of C, you are allowed to use variables to be your array size and variables to be your array size. But I would say we don't do this in 2SH4. Don't assume you can have a variable size array, like the array size to be a variable that you define, because we assume the minimal C89. And in fact, you'll get penalized if you use this in an exam, for example, right? What we mean by a variable size array, the variable size array is you define a variable, you assign it a value, and then you use this as your array size. Don't do that, right? Although it's allowed in most recent C versions, I would say we stick to the safe case, right? Because one example is you don't know your customer which version of C he is using, and maybe he's not using the same version across all platforms. So you want to be in the safe side. So our general rule that we do in 2SH4 is that we do the minimum support that works across all versions. Good. This is a subscript that you use to index a certain element, and we have seen some examples for this. One thing to understand, and this is vital to see, this is different between C and Java, C and Python, and C, in fact, in most languages, is that C, as we will see in coming slides, it doesn't have a boundary checking for you because you handle the memory yourself. As we said before, C is a low-level language, so it's closer to the hardware. It gives you the control to access memory and to control it yourself. It doesn't have a garbage collector similar to Python or Java, as we will see later in the course. So you have to make sure that your index has to be larger than or equal to 0, which is the first element of the array. So if this is your array, regardless of the type you have, you start from 0 and you stop at array size -1, right? If you provide an index that is within this range, that's perfect, right? But if you provide an index that is before that or after that, you might expect that the compiler will give you an error, for example, right? But this will not happen in C because C does not control memory. It doesn't give you safe boundary checking. And that's very dangerous, as we will see in the examples we will cover, right? So yeah, here it's giving an example of the safe index elements. If you define an array size of 6, then the valid elements are from 0 to 5, right? So another thing is you can deal with your, because remember, the array has elements, right? Each element is of type, the whole type of the array, assume it's double, right? So each element is a double variable, which means you can increment, you can decrement, you can use to assign things, you can use in your expressions as if it's a very regular double variable, right? But the array name itself is not a variable, and this is something it's in fact a variable, but it's not a variable that holds a value. What I mean, assume I define my array here to be okay, like a, for example, right? The first element is a of 0. The last element is a. Let's say I have a size of, I don't know, 5. This is a of 4, right? If you use a of 0, you can use in arithmetic operations, for example, but a itself you cannot use in arithmetic operations assuming it gives you a certain value. So for example, if you have 1, 2, 3, 4, 5, just using a itself doesn't give you any of these values. Can someone remember what I said about what is the array name itself? What is going to give you if you use it without any index or subscript? The address, exactly, and how. It's the address of the first element. So if, for example, your array starts from address 0xf, a would hold 0xf. And we will see this later in pointers. So the array name is an address. It's not a value, right? And that's something that will cause a lot of problems if you don't pay attention to. For example, you cannot assign an array to another array because it's like assigning an address to an address, which is not possible. You cannot initialize an array like that because you have to specify the type, as we will see right now. So, okay, one thing we have seen in defining or declaring an array is to give the size. To say, for example, I want int a equals 6, something like this. To initialize your variable array, you can provide all the list of the values you have in these curly brackets, right? Starting from 0 up to the size you have. Good. That means now C of 0 will be 100, C of 1 will be 60, C of 2 will be 30, etc. If you do that, so here we provided a number of elements equal to 1, 2, 3, 4, 5, 6. So you have a total of 6 elements, each one has a value, right? Now, what if I initialize only some of the values, not all of them? They will get assigned in the order. So this will be element 0, 1, 2, 3. But then you have 4 and 5 left. They will get automatically assigned 0 if you don't give them a value. So this is equivalent to as if you are saying 100, 60, 80, 40, and then 0, and then 0, right? These two are equivalent. Good? So we said you have to provide a fixed value, a constant value for the array size. In case you initialize your array, you are freed from providing the size if you don't want to. Why this is possible? Because the compiler will use the number of values you entered as your size. For example, here, if you do this, it will be accepted in C, but then you have 1, 2, 3, 4. So the compiler will recognize that you want your array to be of 4 elements, right? So you provided the number or the array size in an implicit way by providing an initialization. Good? Okay. Another way of initializing an array, and this is what we have seen before in the example of reading 20 integer inputs from the user, is to use a for loop, right? And then iterate all through the elements of your array, right? We said we shouldn't be doing this. Let's say assume it's just 40, but now we are using it for coming versions, right? So you have 100 elements, and then now you are initializing all the elements to be 100, right? Let me see if you have questions first. If I have an array B3 equal 1, 2, 3, what happens if I let it int A equal B? That's not allowed. It will give you a compiler error, and how? You are not allowed to assign the array to another array or another variable, or use the array name in your arithmetic operations for now. Mohammed, can you print contents of an array without using a loop? Well, generally no, right? I would say I don't see a direct way. There might be indirect way, but I would say you have to go through all the elements. What I'm getting is you want to print all the elements of your array, right? You have to access these elements one by one. So you need some sort of a loop, right? Another way, so why I said, okay, this question is kind of an open one, because for example, if I just went through myself without a loop, iterating through all the elements myself, then you have done this without a loop, right? But in fact, it's a loop anyway. Danny, can we do a minus 1 to get the last element in the array like in Python? Danny, this is exactly what I was saying as the difference, the important difference between C and Python. In C, things are not circular. And this is one of the differences between lists and arrays in C, right? So assume this is element 0. This is element, I don't know, m minus 1. You might assume that if you do, and this is A, if you do A minus 1, it will go back to the first element or so. No, this will not happen. It will just access the element before the first element here in the memory. So this element, this is your larger memory, right? And your array is only part of the memory. A minus 1 means take this address of A, do the arithmetic operation here to access the element here. This is not part of the array, right? So that means it's a location in memory. It might not be even safe to access it, right? But C doesn't have this safe checking for you. So if you do A minus 1, you will in fact access this location in memory, which is not part of the array, right? Jill, after defining the array size, if you were to add a value to that array that exceeds the size, would the value be accepted or it would catch an error? This is, yeah, this is also what I was saying, Jill, but on the other side. For example, here, if we have a size of n, if you try to access something like a n plus 1, right? Or an, because the maximum index you have is n minus 1. You might imagine that the compiler might give you an error. For example, in Java or Python, you will get an error telling you that you exceed your array boundary. But in C, you will not. In C, you will try to access this element. But this element is not part of the array, similar to this one, right? It's a location in memory that is adjacent to the array, but it might belong to something else. So it's not safe to access it. But the C will not check that for you. So you have to make sure you check it for yourself. Okay. Inputting values from user, we have done this. So quickly we go through this. You ask the user to input a certain array size, and then you go through these elements one by one, and you ask him to input an integer, for example. We have done this in the first, I guess in the second lecture, so that's okay. So here, if you do something like that, let's see some of the legal and illegal ways of declaring and defining arrays in C, right? If you do that, this will not be acceptable in the compiler. The reason is you already defined the size, it's 6. So it's expecting 6 elements, but you provide 1, 2, 3, 4, 5, 6, 7. So that's not possible, right? If you do something like this, again, it's not allowed because here you are using the array name itself, which we said you shouldn't be using at all, right? Later, when we come about pointers, we will see why this is not acceptable, right? Because this is of pointer type and this is of an int type, right? But generally, for now, don't use the array name in any of the operations or expressions. This is what we were saying, is that C has no array boundary checking at all, right? And the problem is that this error is not detected by the compiler because C is assuming you handle your memory yourself, right? This is the cost here. C is telling you, you have the fine-grained control in your hardware, but you have to be responsible enough to make sure you avoid any problem. I'm not going to do this for you, right? We have given some examples. And we said, for example, here, if you do the array of size 6, that means the last element is 5. But if you try to access 6 element, your program might crash, in fact, because you access something in the memory that you're not allowed to access. Good. Same thing here. Another thing that I have seen in lab 1 problems during office hours is that sometimes you end up even having incorrect loop boundaries, or especially in loops, because it's very hard to pay attention to. And this even might end up having you an infinite loop, right? One example, and it's like the most naive example here, is if you are iterating through an array and you do this, that's wrong. Wrong doesn't mean the compiler will give you an error, but you are exceeding your array boundary. What is the reason for this? Is when you go to the last element, which is size here, you will try to access C size, right? But that's outside of your array boundaries because your array is starting from 0 and up to size -1, right? For example, if this is 5, the maximum element you can access is 4. So if you try to access C5, you are outside of your boundary. So that's unsafe, right? me check questions. Can we say D5 equals C1 to assign index 5 of D to the numerical value of the first index of the array? Yes, assigning, as we said, Danny, array elements themselves are the variables, are the ones that are holding the values. So saying D5 equals C1 is allowed if both are of the same type, because as if you're saying X equal Y, right? If I wanted to continuously append elements to an array, how would I do that? You cannot append, Muhammad. Like you have to define something as fixed size, and then you assign values to whatever you define. But appending in programming means you increase the size of the array. Currently, our arrays are fixed size. They are not dynamically allocated, which means you cannot append values to them. And in fact, one of the questions that I used to see in interviews when I was conducting interviews is, and it's a common array question, is what if you want to, you don't know the number of variables, the number of inputs you would have, but you need to use static or fixed size arrays, what you would do? And the most naive solution is to say each time I exceed my size, I define a new array. I have to copy everything from the old array to the new array, right? And then you double the size, for example. Later, we will see how to handle this very easily using dynamic memory allocation, right? But not yet. Good. Okay, we said the correct one is not use the equal because it will stop at size -1. Arrays and functions, and we see this in one of the questions we have in the lab. A function cannot return an array. Can someone like tell me why? We have mentioned this when we talked about functions. Why a function cannot return an array? Can someone give a hint why a function cannot return an array? Array is an address, can only point to one address, not a value. Yeah, someone wanted to say something? Go ahead.
Yes, I was about to say that because C returns value and array cannot be passed by value, so therefore function
correct. Yeah, so you give it an angle which is correct. There are other angles as well, which is, for example, arrays are holding multiple values, right? They are an address to a data structure, and this data structure in C is not a single variable. Then you cannot return multiple values from a function. But what if I want a function to change an array? Can you tell me how to do this from lab 1? How to make a function change an array, pass the array into the function as an input argument? That's correct, right? And this is what we do in, I don't remember which question, but we do this in one of the questions, I guess the perfect numbers. Yeah, the perfect numbers question, where you pass an array that holds the perfect numbers, you keep updating it in the function, and then at the end, the change will reflect in the caller function. Good. So yeah, this is what Arjun was saying. A function can have an array as a parameter. In this case, the array name is passed to the function because the array name is an address. If we need to write a function to process an array, it's sufficient to pass the function the array name and its size. If a function is passed an array name, then the function is able to access and modify. And this is what I told you before in one of the lectures. This is what is different between arrays and other usual variables when it comes to passing input parameters to a function. Because by default, any variable that is passed to a function is passed by value, which means any change will not reflect in that variable outside the function. We have covered this in details with examples in the first function lecture. But arrays, because the array name itself is an address, so in fact, you pass it by reference by default, which means any change in the array within the function will reflect outside the function. So this is what is stated here. If a function is passed an array name and the function is able to access and modify it, it will be reflected back in the caller by default, right? Here are some examples of making sure that this is what's happening. We define an array, we call it my array. It's a double, we initialize it with some values. And then I'm calling a function called reverse array. This reverse would take the array name and its size. And then we will do the reversing inside the function. And after that, once we go back from calling this function, and we try to print the array, we will see the values reversed, right? So here, let's see the implementation of the reverse. You just take the array as an input. You guys have seen this format in lab as well, and this is the size of the array. What you would do is what we have done at the example in the third lecture, which is reading 20 inputs from the user, print them in the reverse order. We do exactly the same thing here, right? You go through all the elements one by one, and then you try to reverse them, but we are implementing this in a different way here. Good. And then afterwards, we return back, let me see, we return back here. If we print the array after modifying it, you will see the values reversed. So if you print this, you will see something like 2.0, 4.3, etc., until 1.1. Why the change is reflected in the main, which is the caller? Because arrays are passed by the name, which is an address. So it's called pass by reference, right? Let me check questions. Can you say that the scope of arrays are all global? No, that's not correct, Yolanda, because if that's true, I wouldn't need to pass the array at all if it's global. The function itself would be able to access it. The fact that I needed to pass it, that means it's only local, but it's passed by address. So the only change is that when you go to the function, you don't create another variable. You access the same variable as the caller, right? Can we define default value for parameter for function? Post champ. What do you mean post champ, Aaron? There are ways in C you can define default values, but I wouldn't touch this right now, right? And to be honest, I tried this in C++ multiple times, but I'm not sure if C is supporting this. I kind of expect like 90% that it supports that, but I would say for now, let's not talk about this. So what Aaron is saying is that I want to pass inputs to a function, but I want this function to have some default values. For example, if nothing is passed or it's not passed correctly. But this is kind of outside of the scope. So Aaron, we can discuss this offline together because it has some details. Okay, good. Thanks, Aaron. Okay, we already mentioned this. So another way, so here we had an implementation of, if you look into this, one thing we have done is a way of reversing an array. Let's look into the logic of this algorithm, right? Something I'm doing is I'm moving from 0. This is n-1, and this n-1 over 2. And then each time I what I want to do, I want to take this value, put it here, right? Here, and then take this value, put it here. So to do this, I define a temp variable, which is this temp, hold the I value, and then move the n-1 minus I value into the I, and then move the n-1 minus I into the temp. And you keep repeating this. Good. So by doing this, you need only to proceed up to the half of the array. And once you reach the half, you have flipped all the elements or reversing it. This is an efficient solution because you don't have to go to all the n elements. So it's not order of n. The running time doesn't go through all the elements. The loop itself stops at the half of the array size. So if you have a million size array, for example, you only do 500,000, which is half the size, right? But a more, maybe less efficient, but a more straightforward implementation is what we have done in our third lecture, which is simply just do the following, right? Maybe even define another array, and now you are not space efficient, and you just start from the end of this array, place each element here, correct? And then finally, what you would do, so first of all, define second array, then copy elements in reverse order, and then third, can someone tell us what is the third step and the last step? Now I have my elements already reversed in the copied array, right? But there is still one thing I need to do to make sure that the change reflects back in the main. What is that? Any idea? So I had the original array. I created another array, a new one inside the function. I reversed them, copying all the elements but in reverse order. But now I have my update in the new array. But the caller doesn't see the new array, right? Yeah, equate the new array to the old one, Abdul Manim, or basically copy it to the old one. So now copy the new to the old, because the old is the only one that is reflecting back in the mean, right? That's correct. So that's an easy solution, but as you can see, it's not an efficient solution, because first of all, I have to define another array. So you are not space efficient. You occupy more memory than needed. And then the second thing is, you have to go through all the elements of the array. So you do order of n instead of the half of what we have done before, right? Good. Okay, so here, a kind of a third solution without defining another array. So what we want to say is, I'm using my eye to scan the array from left to right, which is from 0 to the maximum thing. And then I have another index, right? J, that is scanning the array from the other side. So here I'm giving you a third solution to visualize it like the following. This is my array. I is starting from here and moving like that. J starting from here is moving like that. And each time I want to swap I and J, right? Practically, this is no different than the previous solution in the previous slide, right? Because you still need to copy things and then you move forward. And in fact, you still have to only move into the half or iterate through the half, but it just makes the indexing easier for you, right? So your I is starting from 0 to the n minus 1 over 2. Your J is starting, this is I, and your J is starting from n minus 1, and it keep moving until n minus 1 over 2, right? So like they move in the opposite direction. Good. Good. Okay. So a question, why this is achieving what we have said here, this range? Because they will only meet if you are incrementing or advancing them using the same iteration, like here you increment by 1, here you decrement by 1, they will only meet at the middle, right? Which is n minus 1 over 2. So once you check is I, here is the array. There are many kind of questions like this in interview type questions or exam questions, right? So this is I, this is J. You keep moving this one by one, you keep moving this one by one. They will only meet and flip at the middle, which means once I is exceeding J, that means you have already reached the half, right? This is kind of a trick that simplifies your condition. Good. Okay. And here we are incrementing I and we are decrementing J, because you are moving J in this direction while I is moving in this direction. Another thing that may be one of the only, I would say not the only, one of the rare conditions where you can use the comma operator that we said we are not covering in this course, and I'm not encouraging you to use even if you know it, is you can add two conditions here within one expression in the for loop. This is saying I want to increment I by 1 and decrement J by 1, both as my expression for the loop iteration. Again, this is not covered in the course. This is just showing that you can use the comma operator here for those who are interested. In fact, a good programming practice is to avoid the comma operator as a whole, right, in your programming. Good. Good. So we said, and this is a question that I was expecting, but I didn't get. So the thing is, we said all the variables are passed to a function by value, which means they are not changed by default. And if you want to change them, you have to send their address. Remember the scanf? We have to send something like this. And then this is num, which means you are sending the address of the variable to allow the scanf to modify it. But then I told you in the arrays, they are passed by reference by default, which means the function is allowed to modify them. But what if I don't want the functions to modify them? What can I do? In this case, you declare your arrays to be constant, which means the function They take it as a constant. That means it's not allowed to modify it. So for example, here, if I'm defining a function that is called sum, which is summing all the elements of X and returning the sum, I don't want this sum logically to change the array itself. It just takes all the elements and add them up, right? So to prevent the function from modifying the array, I'm just passing it as a constant. So if the function tries to modify it, the compiler will give you an error, right? Good. Okay, let me see if there are questions before we move forward. Okay, Ian, that's a good question. No, you cannot use and because that's not a logical expression, right? It's like you are saying, I want to say something like, so let's, okay, let me see, hypothetically, I have done what you are saying, right? Which is I plus plus and j dash dash, right? What this expression will evaluate to, let's see. We have seen this last lecture. Let's say, for example, I was something like 1, right? So here, because this is a post increment, so I would still be 1. And let's say j was, I don't know, like 5. What is the evaluation of 1 and 5 in C? Do you remember? 1 is true, 5 is true, any non-zero value is true, so true and true is true, so it gives you 1. So the expression evaluates to 1, right? Do you see the point? So the end up, the value of the expression will give you something like true, right? So this is not what you want, right? Even if in fact it increments I and decrements j, you end up having a Boolean value as an output, which is not what you are looking for here. Good? Okay, thanks. But that was a good question, in fact. So a local array, you can think of arrays as if they are just very normal variables in the way you define them, in the way you access them, their elements, and in the way you check their scope. So arrays are local by default, like any variable, and they are local to the function that they are defined in, right? Which means a local variable, like any local variable other than array, it only exists in the memory when the function execution begins and when it, like, until it ends, right? Normally as any variable. If you want to keep them in the memory for the whole program duration, again, similar to any variable, like what we have done before for some of the examples, you need to define them as static, right? Okay. Good. Some of the maybe more complex examples of arrays, and we have 5 minutes left. So double subscripted array, all what we have seen so far is only one-dimensional arrays, right? But logically, you would have data structures that can be of 2D, for example, matrices, right? So how to deal with 2D arrays in C? It's very similar to the 1D array. You just add another bracket, which is giving you the second dimension. Here it means you have an array that has columns and rows. These are your rows. These are your columns. And you are accessing element I and j. So you go to row I here. Sorry, is there a question? And then j, this would be the element you are trying to access, right? Good. How to define 2D arrays? Again, very similar to 1D arrays. Let me make sure I mute everyone. There is some noise in the background. Okay, so you define them as if you define a single type, a single dimensional array, but you add the second bracket, right? And you start with the row number and then the column number. For example, here I'm defining an array that has 3 rows and 4 columns. We usually say this is a 3x4 array or matrix, right? The way this 3x4 would happen is that they have 3 rows, as I said, 4 columns, and these are their elements, right? So A00 is row 0, column 0. A12 is row 1, which is this one, and then column 2. Good? So one thing to understand behind the scene, your memory is of sequential nature, right? It doesn't have this 2D nature, in fact, right? because addresses are incremental. So if you access an element with address x, x plus 1 would be the subsequent in the memory. We don't have x plus 1 and then x on the side. There is no side in memory. There is no TD nature, right? So how 2D arrays are stored in memory? They in fact are stored sequentially, row by row. So what you would find in memory is you would start from A00 up to A03. This is the first row. And afterwards, the second row, and then afterwards, the third row. So for example, if I'm starting with address 0x0 here and saying this is int, so each element is 4 bytes, this would be address 4, 8, 12, 16, 20, etc., 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 right? And doing this, there are some tricks, in fact, that you can deal with 2D arrays as 1D only if you want to access them. For example, if I just say A0, it will give you A00, right? If you would say AI here is as if it's an array, which is the row I, right? So two things. So here, for example, this A1 is array on its own, right? Correct? And it's by default pointing, as we said before about array names, they point to the first element. So A1 is the address of this element, but also it points to this array. And the same thing here. So you can think of each row in your matrix as if it's a 1D array. Good? Okay, so this is an example. I guess we are over time. So let me take, we still have 1 minute, but let me take questions and we stop here because I want to go through these examples in a deep way. Okay, Ali, why is using commas discouraged? That's a long story, Ali. Maybe we can discuss on office hours, but it's not a good programming practice. Muaz Akhtar, could you specify a single column or a row in a 2D array or only a single element? Yes, this is what I was saying. You can specify a single row using like the array and one index. This gives you a row. And you can also specify a single element, but there is no direct way of specifying a single column. In fact, one of the tricks or interview questions or exam questions, if you want to access certain column in an array, a 2D array, what you do. For example, maybe you transpose and then you look into the row, then now it's a column, right? Can we put array in C? I guess if you mean by saying, for example, A equal B, that's not allowed in C. I know it's allowed in Python as assigning a list to a list, but as we said, don't use array names in any operations for now. Arjun, what happens if you call just the row number and not the column number? Yes, Arjun, this is what we were saying in the previous slide, which is if you only call the array, like the row number, it's an array of its own, right? So for example, A0, so let's look into this in a 2D way, right? Here you have 3 rows. The first row is A0. The second row is A1. The third row is A2, right? So if you say A0, it's pointing to these 3 elements. Salah, can we save arrays as elements of an array? You have to copy, again, you have to copy element by element. You cannot just assign an element like you cannot say assign an array directly to an array. For example, if you have a 1D array, let's say, for example, I have this 2D array of A, and then I define another array that is of 3 elements, right? Of type 4. Can I just say A0 equal B? Because A0 is the row here, and B4 has the same size, so I can assign this to no. Again, no, right? Why? Because even if they have the same size, this operation is not allowed in C. You have to copy it element by element, right? Because array names are addresses. They don't hold values, right? Nicholas, to answer your question, A0 is the address of the first element of row 0, right? So it's an address, but also it points to the first value, right? So to understand what I mean is I encourage you to try it yourself and see what you will get, right? Second hand, can you use operation on AI0 if A is a 2D array. This is, yeah, okay, Sagnan, this is exactly Nicholas' question, because I was saying, okay, A0 is a single 1D array, and it's pointing to the first element of that array, right? We said you cannot do this. You cannot also do that if you wish. For example, I don't know, like A3 equal A0 directly, but I'm encouraging you to try that, right? And see what you will get. Guys, we are done with content. If someone has another lecture, I'm just taking a few questions before I leave. Aaron, so to get the value, we have to use no, Aaron, right? The AND is giving you, in fact, an address, right? It doesn't give you a value. So assume, for example, I want to get the value of this element, any element, for example, this one. What I just simply do is A00, right? Or I do something like A02 if I want to access this one, right? So use the to index. And will give you an address, right? So it's not what you are looking for. Thanks. But in fact, as we will see in pointers, but I don't want to confuse you, is you can use the asterisk for getting a value, not the AND, because AND is an address, but the asterisk is the value of A0, which would be the first one. We will see this later, but forget about it now. I never programmed in Go, to be honest. I don't know. Okay, good. So yeah, so let's thanks everyone, and let's meet on Tuesday. I'll see you next lecture. And just remind you, like today's tutorial and this lecture, hopefully by end of today or tomorrow, they will be uploaded as well. Thanks everyone. Have a great weekend. Bye-bye.